Good afternoon and welcome back to our video tutorial series on how to create a pickup item in Maya and bring it over into Unreal. In the previous video we set up so that we have our hearts, they have some physics on them, we can pick them up, we have our health displayed down there in the bottom left, and I can't overfill the health, so if I get too much health I can just run around and I can't pick up that heart. Okay. Go ahead and hit escape here. And one thing I want to adjust, because I know I'm going to get a question for it, like in the comments somewhere, is how come this heart does not have, this on there? And that really has to do with the assignment of the colors of this heart object. Because if we go back to our mesh, you can see the default mesh of this object, if we open it up, actually has the base color of the gems on there. It doesn't have the material instance on there. So I'm going to go ahead, and you could actually change it here, but I want to show you that you can also change it in the blueprint, so you can have different hearts with different colors on them at different times. So I'm going to leave this one here. I'm going to actually go to the heart blueprint, so go to my content, blueprints, items, and then my heart blueprint. Let's go to the viewport, and if I select the heart object, you can see we have the base colors here, and I can just change them here. So I'll hit the drop down. So which one am I at? I'm actually at my border color. So the first one is my border. Make sure I get the correct one. Border color instance. So there's that. And you can see I have the gold with the red, which is kind of cool. I kind of like that. But if you wanted the other one, of course, grab my gem color and grab my gem color instance. There's my green. So now if I hit play, you can actually see them in the level here. Except now I'm going to be confused because this one at the end, this one here, I can't actually pick up because that one's not one of my blueprint items. So I'll make sure I delete that one off. Go ahead and grab him and go ahead and delete him off. Alright, so now we're going to set up the fun part for having the heart like rotate or spin or do any kind of physics. So I'm going to go ahead and hit escape and then open up my blueprint. Of course, make sure we save. And then in the event graph, I'm going to come down to my event tick. And the first part is we're going to make it hover. So drag off a wire. And I want a line trace by... let's see. We got line trace. Let's do a line trace. Hi, kitty. We're going to do a line trace by channel. What this is going to do is it's actually going to project a line from the center of the object to wherever and then check a distance. So this is going to help with the hover factor. So if the object raises up, it's going to check how far down. Then it's going to go down and go back. But we need some pieces. So the first part is, if I kind of zoom in on here, we need a start location. So I drag that off. And you can see this is gold or yellow. That just means it's a vector. So if I drag that off, we want to get world location. So get world location. That's going to find out where the object currently is. And then we want to subtract our world location from the ground position. So I'm going to drag this off, and I'm going to go ahead and do a minus, and that's going to get me a vector minus vector. Let's see. Make sure I hit context sensitive there. And I want a vector minus vector. There it is. I'm going to plug this value into the end, but we have to do some math with our vector. To see everything, we're actually going to right click on this bottom input, and down here we have split struct pin. This is going to open up all of the pins so I can choose which one of these I actually want to do math by. And you can see these are all float colored, so I'm going to actually use a new variable. I'm going to drag this off. Up here, I'm going to say promote to variable. I'm just going to call this variable. If you go over to your right, we can change its name. I'm going to call this variable trace length. I'm going to hit compile. And it's complaining that we don't have the world location. We have an error. We just need a reference to our heart. So drag that in and plug that in, because we need a reference to that. Compile. There we go. Let's see. I'm going to grab my trace length. And we're going to do, you can pick whatever value, but for now I'm just going to do 150. And that should be good on this side. So all these talk to that. And now I'm going to come out here, and I need on the hit output, let's go ahead and drag that off. We want a break hit result. If you don't see it already out here, you can just type in break hit. So go ahead and drag that. This is going to tell us, if we touch something, or how far away we are, or if we hit the ground, or whatever. What we want to do here is we want to get our location. So I'm going to drag this off. I'm actually going to do a vector minus vector. So if I type in a minus, make sure context sensitive is on. I'll grab a vector minus vector. And then I want to subtract our current location from our world location. So I'm just going to drag in a reference to my heart object. And from here, from my heart object, I will get world location. Get world location. I'll plug that into the second value there. So our current location minus our world location. And now we want to get our vector length. So drag that off, type in vector length. That's down here. So vector length. And then we want to divide our vector length. So drag off a wire, we'll type in the divide key. And we want to divide float by float. You can see that this is a green, so we want to float. So float by float. And we want to divide our vector length by our trace length. So I'm going to go over to my left, I'll drag in my trace length. I'll do a get. So let's divide our vector length by our trace length. And then we're going to take this output, we're going to run this into a linear interpolate. So type in lerp, go down to float. We want linear interpolate float. So that's a lerp. And as our lerp pops in, it's actually going to have us plugged into this A channel. We don't want to be in the A. I'm going to right click on that A channel and say break link. Now drag off my divide into the alpha. And then for my A value, we just want this to be absurdly high. The higher it is, the more resistance we have on the down. And we'll kind of play with this and I'll show you what that means. But for now, I'll do 250,000. 250 and then 3 zeros. 1, 2, 3. From here, we actually need to get a force value. So here we're going to look for add force. And we want to add the force. We don't want to do the box. We want to do our heart. So make sure you get add force to heart. There it is. And it does come in with the heart reference there, which is nice. We can just use that. Kind of arrange this a little bit better here. I drag off my return value, and I want to multiply my return value by the value of our impact. So I'm going to go ahead and do a little multiplication symbol there. And I'm going to get down here, we want a vector times float. So go ahead and grab that. And the reason we want a vector times float is our impact length, or impact normal. If you come over to our break hit result, our impact normal has a vector type. You can see that. I'm going to go ahead and drag that off all the way over to our return. Go ahead and plug that in. So now we have our trace length, or sorry, our impact normal plugged in here. And that's going to go into our force value. So that goes up here. And then the last thing we need to do is actually tell this thing to work, because right now it's not doing anything. It does all the math, but it still doesn't apply. It won't apply until we hit the play button. So to get that play button going, we need a branch. So I'm going to drag off from our line trace by channel. Drag off a wire, we'll say branch. And then the condition for our branch will be our line trace by channel return. So return value of line trace by channel. So once this result is true, it'll say, hey, go out and do this. And we'll take our true value. We'll just run that right into the force. We'll hit compile. Make sure we save. I'm going to come out here. All right, and then what we want to do is, it's actually best that our objects are not on the ground. But just so you can see what will happen, I'll hit play. Bing! There they go. They're jumping and bouncing for joy. A little too much bounce. That one over there is, he's got the right idea. Look at him, he's kind of calmed down. And grab him. So what you want to do to make sure you don't have absurdly high bounces, it all comes down to the math, but you could, let me go ahead and just move one of these off. So if I raise this into the air, actually let me move one that I can see. This one's already up, so I'll just go ahead and move him off. You want it to start off the ground, and then it'll start hovering. Now you can adjust your trace length. Maybe you can make it 500. The longer the trace length, the longer the tracking distance to the ground. So you can see he doesn't come down quite as far, because 500's about right there. So I'll actually lower my trace length. Let's go down. I'll do let's do 25. Let's see what that gets us near the ground. So we get little jumping beans when we're that close to the ground. Whee! They're just jumping around and giving me health. I hope that one fell over. But you can see by adjusting the trace length, that's basically how far from the ground they have to be before the force effect takes place. And then I'm going to go ahead and put that back. I'll do about 100. Let's go over to our lerp here. And for our A value, let's play with this. I'm going to dial this. I'm going to put a low number in here and just see how high they jump. Boom. So you can see that it's not enough force to kind of push it back up. So you want to go high enough to offset the force. So I'll do like 5,000. We'll see if that's high enough to get a little bit of a kick. Not quite high enough. I'll do 20,000. So you can see why it's an absurdly high number. That's getting closer, and actually if we start from the ground, that's actually not bad. So it's all about kind of picking your battles in this case. Like if you're gonna have this open up out of a treasure chest, maybe that would be kind of cool. Or if you wanted it to be on the ledge of a hill to kind of get the player's attention. So let's like pretend that this was over. We had like a goal, you know. Maybe this was on top of this box here. I'll hit end to kind of snap that down. The way I snapped is I pressed the end key. That's the E and D key. End. My voice is a little bit weird, so I can't always enunciate. So that would like get the player's attention. Oh, there's a heart over there. And then maybe you'd go up the stairs. You're like, oh, wee. Boop. Now I got it. So that's a way to get the hearts bouncing. And then if you wanted to add the spin is actually the easiest part. So I'm going to go ahead and hit escape. Don't forget to save because of Unreal. To add the spin, let's go back to our event tick. So back up to our event tick here. And from here, I just want to do an add local rotation. So I'll drag off a wire. I'll do add local rotation. So add local, so it says, sorry, add actor local rotation. And when we plug that in, you'll see that this pops in and it branches off to our line trace, which is good. We need that. The target is going to be itself because it's weird like that. And then we need to add a rotation value. So I'm going to drag off the delta rotation value. And I'm going to do a multiplication symbol. So we're going to get a scalar rotator. And then we want to rotate this by some sort of value. So I'm going to create a new variable. I'm going to call this rotation rate. And I'm going to make this a float. And the reason it's a float is that's a green input there. I'll hit compile. That way I can get access to the value. And I'll just do like 300. Drag in my rotation rate. I'll say get rotation rate. And then I'll plug that into... Oh, sorry. We need to move this around. For my rotation rate, I got to break that. So we'll say break. Sorry, getting caught up in the moment. Our delta seconds is going to go into here. And then from here, we actually need to add a rotation rate. We need a make rotator. So I'm going to drag off my rotation rate. I'll do make rotator. So make rotator. There it is. And we'll plug in the return value. You can see the return value to that is the correct color. And then you want to plug your rotation rate into the channel that represents which direction you want to rotate. So if you wanted to rotate on the X, that's going to be rotating along the X-axis, the Y-axis, or the Z-axis. In our case, we want the Z-axis because our object stands up. So up is the Z-axis, so we're actually rotating. Let's look at this cross as an example. So this is up and down, so we want to rotate along this axis. If we set the X value, we would rotate along like this axis. And if we set the Y value, we would rotate sort of this way. And we can see that if I hit compile and I jump in, we'll see these things are kind of doing their own. They're like flipping around, and this one's doing somersaults. Yeah. So I'm going to open that up. Kind of ignore that error there. It's just complaining. I'm going to break this one. I'll put that into the Z value. Compile. And then I'll play. So those are rotating in the correct direction. And if you wanted to spin the other way, you'd do a minus Z value to change it to like the other. What are they currently going clockwise? So minus would be counterclockwise. And of course I can grab these. These ones are hitting each other, so they're just kind of flopping around. Now this is one of those things where earlier I said for this particular object, having them being able to hit each other or collide with anything isn't necessary. You could actually turn the collision for them off. to do that, if you're interested, go into the actual object itself. So we're going to go down to Mesh, and then our heart object. And in our heart object, we actually have an option to remove the collision. So if I scroll down, come down to collisions, and you have collision preset, collision complexity. We can actually view the collision. If I go to view collision, I say simple collision. So this is what's currently on there, right? You could just delete the collision. So under collision, you can go down to remove collision, and then it would never collide with anything, which is fine. You could do that and it would work. The other thing is you could come down to the collision preset here, and you could change where it says block all. You could change it to, you could say no collision. That way you still have the collision boundary, but it just doesn't respond, which should work. Sometimes it doesn't. So for example, like if I try it, let's see if it goes. Hit play. So you can see the collision is actually still working even though I told it not to. So I'm gonna go ahead and go back in. So the other option, like if you find that this doesn't work, you can always remove the collision boundary. Now I kind of like this one. I really don't want to remove it, but whatever. You can always make another one. I'll go up to collision. If you can always remove it. And if you remove the collision and you want it back, you can try this 18 dop. And there you got that. So if you ever remove it, that's how you can kind of get it back. I'm going to go ahead and remove the collision. When we do that, we're going to actually see this object jump because it uses the collision boundary to figure out like its mass. So, boom. There they go. But they no longer hit each other. You can see they pass through. And I can just change my trace value. So if I go down to the blueprint, open up the blueprint, I could play with the trace value here, or I could change this to something lower. Let me try like 500. See how high they jump. They fell through the floor. That is another downside. If they have no collision, they will fall through stuff. Try 1500. Well, that seems to be working. And I can still pick them up and gain my health. Deet. Okay, so that's how to create a custom item and bring it in, pick it up, assign it some values. Hopefully you've had a good time with this one and that it's been educational for you. If you like this video, feel free to hit the like button or subscribe, and I will see you guys in the next video. Take care.